Okay, so welcome to part 2 of this video, welcome to part 6 I think it now is of this video, where we are calculating the variance of this hypergeometric distribution. Okay, so we just figured out that the probability of you getting a white marble in both position 1 and position 2, or arbitrarily in position I and in position j, is given by this formula here. So the random variable x1, x2, which ascribes a 1 only if you have a white marble in position 1 and position 2, is Bernoulli distributed with probability w times w minus 1 over w plus b times w plus b minus 1, basically. Okay, so now what we can do is we can calculate the expected value. So if we go back here, what we needed to calculate was the expected value of x1, x2. So if we calculate the expected value of x1, x2, then it is, by definition, it's the sum over every possible value that x1, x2 can take on, which is easy because it can only take on 0 or 1, of that value times the probability that, let's say, x1, x2 is equal to that little value x. So basically what we get is 0 times the probability that x1, x2 is equal to 0, plus 1 times the probability that x1, x2 is equal to 1. Okay, and this obviously just goes because you've got 0 times something, which is still 0, and this here, the probability that x1 times x2 is equal to 1 is what we've just taken pain to work out. It's equal to this number here. So that's equal, this expected value becomes w times w minus 1 over w plus b over times w plus b minus 1, basically. Okay, now all we need to do is work out these terms here, the expected value of x1 times the expected value of x2, but those are just Bernoulli random variables. So x1 is distributed Bernoulli with probability, we've seen w over w plus b. So remember, x1 is the random variable ascribing you a 0 or 1 depending on whether the first ball is a white ball or a black ball, and the probability of it ascribing a 1 is therefore the probability of picking a white ball, which is w over w plus b. And similarly, x2 is the random variable ascribing you a 1 or a 0 depending on whether your second ball is a white marble or a black marble, and the probability of getting a 1 is therefore the probability of getting a white marble, which is again just w over w plus b. So basically what we therefore get is that the expected value of these two, we've calculated the expected value of a Bernoulli distribution up here. It's exactly the same calculation here. You have the two possible values, 0, 1, and all you get is 1 times the probability of success, basically, of this 1. So both of these are just equal to w over w plus b. So the expected value of x2 is just equal to w over w plus b. So what we find, therefore, putting it all together, is that the covariance of, I'll stuff it down here, x1, x2, is equal to, well, it's this expected value of x1 times x2, this thing here, w times w minus 1 over w plus b times w plus b minus 1, minus these two things times together, which is the expected value of x1 times the expected value of x2, which is w over w plus b squared. Okay, so that's not what we wanted to work out, though. We wanted to work out, remember what we wanted to work out was the variance of the whole random variable, big X. So we now have the variance of an arbitrary random variable x subscript I, and we have the covariance of an arbitrary choice of two random variables, x subscript I and x subscript j. Because, as I've said, the symmetry of this means that whatever random variable you pick here, x1 through to xn, it's the same value, and whichever two random variables you pick here through 1 through j, through n, sorry, again it will be exactly the same value. So basically we get that, therefore, okay, so the two things we've worked out are that the variance of a random variable xi is equal to, I believe, w over w plus b, and then we had b over w plus b, I believe it was. Let me just check that was what we got. Where did I get that? Here, yes, so that's that answer. And we got that the covariance of, let's say, xi, xj was equal to w times w minus 1 over w plus b times w plus b minus 1 minus w over w plus b squared, basically. Right, okay, so now let's use those to work out this great variance here. So the variance of x, which is the random variable telling you how many white marbles you overall pick out. So it's the random variable ascribing to every single outcome how many white marbles you in total picked out, is equal to the sum of all the variances, which is just the sum of a constant, this constant here. So basically that becomes how many of them you sum up times this constant. So you sum up n lots of that constant and you get n times w over w plus b times b over w plus b. Okay? And then we get plus 2, and again we're summing up this constant here, so I'll put this hideous constant in, w minus b over w plus b times w plus b minus 1 minus w over w plus b squared. Okay, so we've got this constant, and now all we need to work out is how many times we sum it up. So if you, for instance, if you sum up a constant 3 and you sum it up n times, then the total number you're going to get is going to be 3 times n. That's what we're doing basically here. So how many sums are we going to get up here? Well, it's the total number of ways of picking two random variables, xi and xj. So for instance, of picking x1, x2, x2, x3, it's the total number of pairs you can pick where order does not matter. So x2 and x3 is the same as x3, x2, and that's just n choose 2. So we put in n choose 2 there. Okay, so this becomes n times w over w plus b times b over w plus b. So all that remains to do now is to simplify everything that this is to try and get it into a nicer form. Okay, so we've got n times w plus b times b times over w plus b plus, now if we expand the n choose 2, it will give us plus n minus 1, and then you would get over 2 factorial, but the over 2 factorial cancel with the 2 here, and we'll get times this constant, w times w minus 1 over w plus b times w plus b minus 1 minus w over w plus b squared. Okay, right, now pull out, there's a common factor everywhere, which is w over w plus b, and there's a common factor of n. So we'll pull out that and we'll get n times w over w plus b, and then we will have b over w plus b. We'll have plus n minus 1 lots of w minus 1 over w plus b minus 1 minus w over w plus b. Okay, and we'll continue this in the next video.